Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, and we were discussing unit 8 redox reaction, and in this video we will discuss balancing of redox reactions by half reaction method or ion electron method. Now in half reaction method, the two half equations are balanced separately. So redox reaction is split into two equations, oxidation half reaction and reduction half reaction, and they are balanced separately and then added together to give balanced equation. Okay, so first we will discuss different steps of this method. In step 1, write skeletal equation for the reaction in ionic form. Step 2, separate the equation into half equations, that is oxidation half equation and reduction half equations. Step 3, balance the atoms whose oxidation numbers are changed in each half equation individually. Then step 4, in each half equation, balance oxygen atoms by adding H2O and H atoms by adding H plus ion if reaction is taking place in acidic medium. For the reaction in a basic medium, first balance the atoms as is done in acidic medium. Okay, that is, if reaction is taking place in the basic medium, also balance the hydrogen atoms by adding H plus ion. Then for each H plus ion, add an equal number of OH minus ions to both sides of the equation. Where H plus ion and OH minus ion appear on the same side of the equation, combine these to give water. Step 5. In each half equation, balance the charge by adding electrons and make the number of electrons equal in the two half equations by multiplying one or both half equations by appropriate number. Step 6. Add the two half equations to achieve the overall equation and cancel the electrons on each side. And last step, step 7, verify that the equation contains the same type and number of atoms and the same charges on both sides of the equation. Now let us discuss some examples. Balance the equation showing oxidation of Fe2 plus ions to Fe3 plus ions by dichromate ions, that is Cr2O7 2- in acidic medium, wherein dichromate ions are reduced to Cr3 plus ions. So first of all, we will write step 1, that is skeletal ionic equation. Now reactants are Fe2 plus and dichromate ion, and products are Fe3 plus and Cr3 plus. Clear? Now step 2, separate the equation into two half equations. To separate in oxidation half equation and reduction half equation, first of all we have to find out the oxidation number of each atom. Then we have to see change in oxidation number. Okay, so in case of Fe2 plus, oxidation number of iron is +2 because this is monoatomic ion and charge on monoatomic ion is equal to its oxidation number. In case of Cr2O7 2-, the oxidation number of oxygen is -2. Okay, and by using the rule, in case of polyatomic ions, the sum of the oxidation number of all the atoms is equal to charge on it. So if we use this formula and calculate the oxidation number of chromium, then it will come +6. Oxidation number of each chromium atom in Cr2O7 2- is +6. Oxidation number of Fe3 plus is +3. Oxidation of Cr3 plus is again +3. Okay, so just see, in case of Fe2 plus, this is changes from +2 to +3. This is increase in oxidation number. So we can say this is oxidation half equation. Oxidation half equation is Fe2 plus converting into Fe3 plus. And this there is a change in oxidation number of chromium from +6 to +3, decrease in oxidation number. So this represents the reduction half equation. This is the reduction half equation, Cr2O7 2- to Cr3 plus. Is that clear? Now step 3, balance the atoms whose oxidation numbers are changed in each half equation individually. So in oxidation half equation, the number of atoms are already balanced, one Fe in the reactant side and one Fe in the product side. Okay, but in the reduction half equation, there are two chromium atoms in the reactant side. Okay, But in the product side, there is only one chromium atom. To make two chromium atom in the product side, we will put here 2. So this equation Cr2O7 2 minus converting into 2Cr3 plus. Then step 4. In each half equation, balance oxygen atoms by adding water and hydrogen atoms by adding H plus ion, because this reaction is taking place in the acidic medium. So in case of oxidation half reaction, that is Fe2 plus converting into Fe3 plus, there is no oxygen and hydrogen is there. So no need to add H2O and H plus. But in the reduction half equation, just see, in the reactant side, there are the 7 oxygen atoms in Cr2O7 2 minus. So to balance the oxygen atom, we will put 7 water molecule in the product side, 7H2. Okay. Now just see the hydrogen atoms. Again in the reactant side, there is no hydrogen atom. But in the product side, how many hydrogen atoms are there? This 7H2O. So we can say there are the 14 hydrogen atoms in the product side. So put 14H plus in the reactant side. So equation becomes Cr2O7 2 minus plus 14H plus converting into 2Cr3 plus 7H2O. Clear? Now in step 5, in each half equation, balance the charge by adding electrons. Okay. So first of all, calculate the charge in each half equation on both the sides. In case of this, that is oxidation half reaction, in the reactant side plus 2 charges there, and in the product side plus 3 charges there. So how many electrons we have to add? Actually this is the oxidation, and in terms of electron transfer, what is oxidation? Oxidation is the loss of electron. So loss of electron will be indicated in the product side. So we will add the 1 electron in the product side. Clear? So our equation Fe2 plus gives Fe3 plus electron. Okay. Now just see, in this we have to balance the charge. Now in the, again calculate the charge in the reactant side, Cr2O7 2 minus, that is 2 negative. Okay. In 14H plus, we can say that is 14 positive. So net 12 positive. In the product side, 2Cr3 plus, each chromium ion carries 3 positive charge. So 2 chromium ion plus 6 positive charge. Okay. And water molecule is neutral. So in the product side plus 6 charge is there, and in the reactant side plus 12 charge is there. So how many electrons should be added? In the reactant side, we will add the plus 6 electron. Clear? To make the charge equal. We can also understand, actually this reaction indicates the reduction. And what is reduction? Reduction is the addition of electron. So in the reactant side, we will add the 6 electrons. So our equation becomes Cr2O7 2 minus plus 14H plus 6 electron converting into 2Cr3 plus 7H2. Okay. Now these electron lost and electron gained should be equal. Okay. So in the oxidation half reaction, there is the 1 electron is lost, and in the reduction half equation 6 electrons are gained. To make equal, the oxidation half reaction is multiplied by 6. Okay. So we will get this equation. Okay. Make the number of electrons equal in two half equations by multiplying oxidation half equation by 6. So 6 Fe2 plus converting into 6 Fe3 plus 6 electron. Clear? Now, after balancing the charge, we can write these equations like this. Same equation. 6 Fe2 plus converting into 6 Fe3 plus 6 electron. This is the oxidation half equation. And Cr2O7 2 minus plus 14H plus 6 electron converting into 2Cr3 plus 7H2O. This is reduction half equation. Now step 6. Add the two half equations to achieve the overall equation and cancel the electrons on each step on each side. Now for this step, we have to add the two half equation, and for this purpose, first write the reactants of both the sides, reactants of both the equations together. Okay, so in this reactant is 6 Fe2 plus, so this 6 Fe2 plus. Now in this reactants are these, so this. Okay, then again write the products of both the half equations together after the arrow mark. So products in this oxidation half reactions are this 6 Fe3 plus plus 6 electron, and in the reduction half equation products are these 2Cr3 plus 7H2. Now whatever the common in reactants and products, make them cancel. Okay, so you can see that is this 6 electron is cancelled by this 6 electron, so we will get this final equation 6Fe2 plus Cr2O72 minus plus 14H plus gives 6Fe3 plus 2Cr3 plus 7H2. And last step is again verify. Now in this verification we will verify the each atom same or not on both the sides, number of each atom, and we'll also verify the charge on both the sides. Let us see. Now in the reactant side 6Fe, in the product side 6Fe. Clear? Now in the reactant side 2 chromium, in the product side 2 chromium. Let us see oxygen. In the reactant side 7 oxygen atoms, in the product side 7H2O, so we can say 7 oxygen atoms are there. In the reactant side 14 hydrogen atoms are there. So in the product side 7 7H2O, so we can say 14 hydrogen atoms are there. So this is our balanced equation. Clear? Now let us see one more problem. Problem 8.10. Permanganate 7 ion, that is MnO4 minus, in basic solution oxidizes iodide ion, that is I minus, to produce molecular iodine I2 and manganese 4 oxide, that is MnO2. Write a balanced ionic equation to represent this redox reaction. Okay. Step 1. First write the skeletal ionic equation. Reactants are permanganate ion MnO4 minus and iodide ion I minus, arrow mark. Then products are manganese 4 oxide, that is MnO2, and molecular iodine, that is I2. Now step 2. Separate the equation in two half equations. To separate, first we have to find out the change in oxidation number, and to find out the change, first of all we assign the oxidation number for each atom. So in case of MnO4 minus, oxidation number of oxygen is -2, and again we apply the rule that in case of polyatomic ion, the sum of the oxidation number of all the atoms is equal to charge on that ion. Then we will get the oxidation number of Mn plus 7. Okay. For iodide ion, this is monoatomic ion, so its oxidation number is -1. In case of MnO2, oxidation number of oxygen is -2, and if we calculate, we will get the oxidation number of Mn plus 4. In case of I2, now I2 is present the elemental state, so oxidation number of each atom is 0. So this is 0. Now see the change. Mn, this is +7 to +4. This is decrease in oxidation number. So this is reduction half equation. So we can write this is the reduction. MnO4 minus converting into MnO2. Now this is I minus -1 to 0. Clear? This is increase -1 to 0. This is the increase in oxidation number. So this is our oxidation half equation. I minus converting into I2. Now step 3. Balance the atoms whose oxidation numbers are changed in each half equation individually. So in case of oxidation half equation, we will balance the iodide in both the sides. So 2I minus converting into I2. Now in case of reduction half equation, Mn and oxygen atoms are there, but there is no change in the oxidation number of oxygen atoms. So, and change is taking place in the oxidation number of Mn, but Mn in both the side is 1, 1. So it is not necessary to do anything with this equation. Okay. Now step 4. In each half equation, balance oxygen atoms by adding H2O and hydrogen atoms by adding H plus ion. So again, in case of oxidation half reaction, there is no oxygen and hydrogen is there, so no need to add H2 and H plus. But in case of reduction half reaction, if you see 4 oxygen atoms are in the reactant side, so we will add in the 4 oxygen atoms in the reactant side, and in the product side 2 oxygen atoms are there. So in the product side we will add 2H2O to make oxygen equal. Okay, then make the hydrogen atoms equal, and this is in basic medium. But as we have discussed, first of all we balance the hydrogen atoms by adding H plus ion. Okay, so again see in this, in the reactant side no hydrogen atom is there, but in the product side there are
2H2, it is 4 hydrogen atoms are there. So in the reactant side we will put 4H plus. So our equation becomes MnO4 minus plus 4H plus converting into MnO2 plus 2H2. Clear? But this reaction is taking place in basic solution. Therefore 4H plus ions, 4H plus ions, we 4H plus ions, we add 4OH minus ion to both sides of the equation. Okay. So in the reactant side we put 4OH minus ion. In the product side we put 4OH minus ion. But in the reactant side, this 4H plus and 4OH minus, if we combine, we will get the 4H2O. So equation becomes this: MnO4 minus plus 4H2O converting into MnO2 plus 2H2O plus 4OH minus ion. Now again, in the reactant side 4 water molecule, in the product side 2 water molecules. So we can say net 2 water molecules will remain in the reactant side. So equation becomes MnO4 minus plus 2H2O converting into MnO2 plus 4OH minus. Clear? Now step 5. In each half equation, balance the charge by adding electrons. Okay. If you see, our oxidation half reaction is 2 minus converting into I2. 2 negative charge in reactant side and 0 charge in the product side. And this is the oxidation reaction. In terms of electron transfer, what is oxidation? Oxidation is the loss of electron. And these loss of electrons will be indicated in the product side. So in the product side, we will add 2 electrons. Clear? So our equation is this. Now, in case of reduction half equation, if you see the charge, this is -1 in the reactant side, and in the product side, this is -4. So in the reactant side, we will add the 3 electron. And this is the reduction reaction, addition of electron. So equation becomes MnO4 minus plus 2H2O plus 3 electron converting into MnO2 plus 4OH minus ion. But again, number of electrons gained and lost should be equal. In the oxidation reaction, 2 electrons are lost, and in the reduction reaction, 3 electrons are gained. So to make them equal, what we will do? Oxidation reaction is multiplied by 3 and reduction equation is multiplied by 2. Okay, so we will get this reaction 6I minus converting into 3I2 plus 6 electron. This is our oxidation reaction after multiplying 3. In the same way, reduction reaction is also multiplied by 2. So we will get 2 MnO4 minus plus 4H2O plus 6 electron converting into 2 MnO2 plus 8 OH minus ion. Now step 6. Add the 2 half equations to achieve the overall equation and cancel the electrons on each side. Now for this purpose, first of all write reactants of both the equations together. Okay, so in this you can say that is oxidation half reaction, reactant is only 6I minus. So this is 6I minus. And in the reduction half reaction, reactants are these. So write these reactants here. Now arrow mark, then put products of both the equations together. So in the oxidation half reactions, these are the products. These are here. And these are the products of reduction half equation. Same 8 here. Now whatever the common on the both the sides, cancel them. So you can write that is this 6 electron is cancelled by this 6 electron. So net equation is 6I minus plus 2 MnO4 minus plus 4H2O converting into 3I2 plus 2 MnO2 plus 8 OH minus ion. And again step 7, verify number of each atom should be same on the both the sides and charge it should also be same. So let us check 6 iodine in the reactant side. This is 3I2, 6 iodine on the product side. Manganese in the reactant side 2. Okay, 2 Mn. So in the product side again these are the 2 Mn. Now check the oxygen. Oxygen, that is in case of 2 MnO4 we can say 8 oxygen atoms are here. And 4H2O, 4 oxygen atoms are here. So total oxygen atoms are 8 plus 4, 12. Now let us see. 12 oxygen atoms are in the product side. That is in case of 2 MnO2, 4 oxygen atoms are here. And 8 OH minus. Again 8 oxygen atoms are there. These are again 12. Now again check hydrogen atoms. In 4H2, 8 hydrogen atoms are there. In the product side, 8 OH minus ion, that is 8 hydrogen atoms are there. Now verify the charge. In the reactant side, 6I minus, that is minus 6 is here. And this is each MnO4 carry 1 negative charge, and 2 MnO4 will carry 2 negative charge. So minus 6 minus 2, water is neutral. So total charge in the reactant side is minus 8. Now just in the product side, I2 is neutral, MnO2 is also neutral, and this is 8 OH minus ion. We can say that is minus 8 negative. So we can say that is 8 negative charge is there in the product side. So 8 negative charge in the reactant side, 8 negative charge in the product side. Charge is also balanced. Okay, thank you.